Hi everyone. In this series of videos, I will show you some MATLAB techniques. First, I'm going to teach you how to generate the images from your GPR data. I know that most of you have already done so and have the code and definitely know what to do. But let's start from the very first base. Then, after the generation of the image, the B-scan image, we will go to learn how to plot A-scans. And then I will teach you some very basic functions for image processing, like the ones mentioned in the last week's lecture notes. So we can get ready for your final project. Okay, let's begin. Now, we can either work in a new script or a new live script. The advantage of live script is that you can actually see the code and see the results of the code you run here in the workspace. But it consumes much more memory. So if you have a memory problem or your laptop is not very powerful, you might have some problems with it. Of course, there is an alternative here using two percentage signs. You can actually segmentize these different parts of the script so we can run them individually at a certain time. But for the sake of this course, let's work in a live function. Sorry, in a live script, because it is more comprehensive. Okay, let's begin. GPR instant image generation. First, we have to load the image. Remember to be in the same directory, and all your files have to be in the same folder as your MATLAB directory. You can change it using this button here. So let's name it bscan, for example. Use the load function. Let's generate this image. We can use the semicolon so results don't show, which is very memory efficient. We can leave it off, and you can see the image array here. Depending on if you want to see a variable or the result of your code which you just ran, you can leave it off, or else you can leave it on. I suggest that you should leave this off, leave this on most of the time, unless you want to actually see the variable. All right, then we have to determine the GPR distance, which is 45 inches in this particular image, and the GPR depth, which is 20 inches. What else? Then we have to assign the array dimensions to A and B. And to remember later, we know that for GPR, the rows represent the cross range and the columns represent the range. So using the size function, we can extract the number of rows and the number of columns. Now let's leave the semicolon on. As you can see in the workspace, you have loaded the bscan, the image array is 887 by 249, and you can see it here as well, that we assigned it to A and B. Now the next step is to determine cross range and range resolutions. GPR distance divided by A, and dr is GPR depth divided by B. Remember that A represented the cross range and B represents the range. And the next step is to determine the actual Rx equals to A times drx, and R is 1 until B times R dr. And the image is ready for generation. We use this command figure, which determines a new figure. Meaning what? Meaning that all the axis properties are actually resetted here. And for example, if you want to generate different images, different plots, you might set different font sizes, different grids, different axis properties in summary. And if you don't actually use this figure, type this figure function, figure syntax every time, you might actually confuse and mix up different variables and different characteristic properties of each different plot. So when you use this figure, you tell MATLAB that reset everything. This is a new plot with its own distinctive default properties. And also give it a name. Say, for example, figure 1. We use the command image sc to generate the images. Our x-axis, we want to be our x. Our y-axis is r. And the third argument is the intensities, which represent the image. The intensities of each image is in the image array itself. So let's generate the image and see what happens. Okay, this is our image. As you can see, the cross range is correct. It's 44 inches, and the range is up to 20 inches. And we can see the rebars here. Now, what can we change to make this image better? First of all, I use the transpose sign here. Let's see. As you can see, the image is not generated correctly in the right orientation. Therefore, using this sign, we have to transpose it. This is what you use to transpose. Alternatively, you can use bscan.transpose. Currently, this is not correct. So we use the help. We go to see the documentation. Okay, the documentation says that this is the first way to do it, and this is the second way. So every time you forget something, you can just easily refer to the documentation, either by typing help, the name of the syntax you're looking for, or doc. For example, display. There is a lot of examples and explanations and different ways you can work with each function. So you can use either this way or the other way. All right. Now we know that you have to transpose the image in order to see it correctly. What else can we change? We can determine the labels. For example, cross range. Make it italic. And give it a y label. We can also give it a title. For example, concrete wall. We can also change the font size using the GCA handle. A stands for axis. So using the send function, we're actually determining the axis properties. We can refer to the documentation for the axis properties. For example, we can change the font size to 14. Oh, sorry, this is not the way to do it. Now this is great. Now, for example, we wanted to actually see what the font size was before this. Now we know that we now assigned it to 14, so it's going to be 14, but you can use the get function to actually see all the axis properties here. And you can use dot indexing to extract each of them. For example, let's find font size, font weight, font name. For example, line width. Oh, font size is here. We can set h.font size. So we can leave the semicolon off to see it. So it's 10. You can also change it from here. So there are two ways to do this. You can use either way. And we'll go back to the main one that we used using the set function. We can also give it a subtitle. For example, the apparent dielectric constant that we put in the device is 5.5, for example. We can also change the color map. So first of all, we want to see a color bar here. Now we can see a color bar. And actually put it here to the axis. Now we can determine the color map. For example, we can change it to jet. There are many options. You can change it to HSV. You can change it to cool. Change it to hot. We can use the documentation color map to see a list of different color maps. And for example, here we can see a list of color maps and their names. All right. Let's keep it at jet. Now, one of the most important things that you'll need to learn how to work with is the color game, which can significantly impact the way you interpret your data. You can change the color gain using the c-axis function. For example, Here we can see the color gain is from approximately -1 to 1.5 or something, or 2 to the times 10 to the power of 7. So we can, for example, change it to -3 and 3. You can also play with this color gain so we can see more features. Or hide the useless data. So I'll leave this to you to find the optimum z-axis so we can interpret the results correctly. You can also change the aspect ratio so you can see your images correctly. Again, we can either use the dot indexing, we can get the GCF handle. GCA is axis properties and GCF is figure properties. And you can set y direction. You can change position, just like before. But we can use the set function again. This one is your X position. This one is your Y position of how the image actually shows on your screen. The next value is the width, and the next value is the height of the generated image. So let's see what happens. Okay. Now, when I open this, you can see that it pops up here. This is the 500-500 position that I gave it. Now, if you change this, the position changes accordingly. So this is how you can generate your B-scan images, and you can play with the color axis, with the z-axis value, the color gain, so you can determine the best optimum color gain to interpret your images correctly.